Assalamu alaikum students. Okay, so today's topic is hyperbolas. It's a standard form, types of hyperbolas, and graphing hyperbola. Hyperbola is set of all points in a plane where the difference between two fixed points is same. So those two fixed points are the foci, and any point on the hyperbola from that point, the difference of the distance between the two fixed points, these foci, these difference would be same. However, in ellipse, the sum of the distance is same, but in hyperbola, the difference of the distance is same. So in this case, distances d1 minus d2 remains constant for all points on the hyperbola. There are two types of hyperbolas: horizontal, when it opens, these hyperbola opens left or right, left and right, this is a horizontal. When the hyperbola opens up and down, it's a vertical hyperbola. Okay, so now let's plot the name the points, the special points of the hyperbola. How to identify the horizontal and vertical hyperbola from its standard form? In the standard form, x squared will be positive for the horizontal hyperbola. For the vertical, y squared will be positive. So let's start naming it. This is the center of the hyperbola. The points where it touches, where the hyperbola touches this x-axis is the vertex. This is the vertex. This is the vertex. And the points inside each branch of the hyperbola are focus. The plural of focus is foci. So the points inside the branch, and the focus and the vertex will always be on the same axis. The other 2 points on the other axis, this is the conjugate axis, this is the transverse axis. Now transverse axis and the conjugate axis, in ellipse, those were major axis and the minor axis. But in hyperbola, this is not the major axis, it's the transfer axis, which when it's a horizontal hyperbola, the transverse axis will be a horizontal line. If it's a vertical hyperbola, the transverse axis will be the vertical line, and the vertex and the focus will be on the transverse axis. Now in hyperbola, a is not the largest number. A could be any number, but it is the first number which is under the positive variable x or y. Okay, so the distance from the center to the vertex is a. This is a. This is a. Distance from the center to, okay, the points on this conjugate axis are the co-vertex, and these 2 points help us co-vertex. These points, the distance a and this distance b, help us to create the reference box. Now to create a reference box, we are going to go a distance to this side and b distance up to get the 4 corners. A distance and b distance to get the 4 corners. From the center, a, b distance, a and the distance b to get the 4 corners. This is also the distance c, which is exactly same as the center to the foci. Okay, so now let's name it on the vertical hyperbola. This is the center, as it is the vertical hyperbola. This will be the vertical axis will be the vertical line will be the transverse axis, and the other one, this is the conjugate axis. The points inside branch are the focus, the inside of the hyperbola, and the points where it touches the box are the vertex. This is the distance A. The other points on the conjugate axis, this point B just helps us how the hyperbola is spread out. We are using this B distance to get this point, B distance. This distance is similar to this distance, okay? And this is C. So this is the co-vertex. Co-vertex. Okay. Now let's begin. The center HK is the midpoint of foci, or it's the midpoint of the vertex too. Okay. The vertices are the turning points, or the vertices or the turning points are plus minus A units away from the center. So this is A, this is A, okay, plus A from the center, minus A from the center. The co-vertices are plus minus B units away from the center. These are the co-vertex, plus B, minus B from the center. The transverse axis connects the vertices and has a length of 2A. So this is the transverse axis here. This from here to here. This is the transverse from A to A. From this distance A and this distance A gives 2A. The conjugate connects the co-vertices and has a length of 2B. The asymptotes are diagonal lines that guide the curves. So the asymptotes, these are the lines, imaginary lines, where the function approaches but never touches. These are the imaginary lines. And they go through the corners of these reference boxes. We will learn how to find the equations. The other way, the simplest way when graphing is to just use the center and the corners of these reference points and connect the asymptotes. The two asymptotes, they will be similar, just one will be positive. This is the positive slope and this one will be the negative slope. The reference box just shows the amount of stretch x and y go in which direction. So x and y means x, how much this x-axis stretched, and how up y coordinate stretched. It is determined by A and B. Okay, so the foci are plus minus C units away from the center. The foci in this case we get by adding the squares of A and B, because it's formed by the Pythagoras theorem. You could see A and B. A squared plus B squared equals to the C square. Here it is C. It makes a 90 degrees. So that's how we are going to use our these points. We are not going to measure this unit distance. We will just go A distance, this, B distance up, and we'll get the reference box. C is the distance from the center to the foci, and it's also the same distance, and it's also the same thing from here to the end of the reference box. It's the same thing. C is this also, and C is this also. Okay. Standard form of the horizontal ellipse is when x is positive, x squared is positive, x minus h whole squared over a squared. A squared will be always under the positive variable, minus y minus k whole squared over b squared, and they're both equal to 1, and there is a minus sign in between. There's not a plus sign in between. In ellipse we used to have plus sign in between. Okay, and in ellipse the difference was a was always the bigger number, but in this case a could be a smaller number, but a is under the positive variable. You can see y is a negative. However, you will square this y even though this minus will stay there. So a always comes under the positive variable. The transverse axis for this one, the equation for the transverse. So these help us to find the equations, all these three. So the transverse axis is the horizontal line when it's a horizontal ellipse, hyperbola. So the h coordinate will help us to find the equation. The transverse axis for the horizontal one is a horizontal line. So to find the horizontal line, we will be using the k coordinate. Y equals k. For the vertical line, the conjugate axis, we will be using the h coordinate because h stays the same. So the conjugate will be x equals to h. The equation of the asymptotes will be y equals plus minus b over a x minus h plus k. Let's do the standard form of the vertical hyperbola. Y will be positive, so y comes first. Y minus k whole squared over a squared. A will be only under the positive variable. Minus x minus h whole squared over b squared equals to 1. It's opposite to what the horizontal hyperbola is. For the transverse axis, it will be x equals to h, and for the conjugate axis, it will be y equals to k, because the conjugate axis is the horizontal line. To find the horizontal line, we will use the y coordinate. The equation for the the asymptote for this one will be y equals plus minus a over b. If it's the vertical, it's going to be a over b, x minus h plus k. If it's the horizontal, it is b over a. Well, when we will be using just to write an equation. Otherwise, the easiest way to graph the equation is to just use the corners of the reference box and the center. Graphing the hyperbola. Write the equation in standard form. The first step. Graph the center. Graph the vertices using the first denominator a, which is always under the positive variable. Graph the co-vertices, use the second denominator b. Now, after this, we will be drawing the reference box using a and b. Okay, and then we will be using the formula c squared equals a squared plus b squared to find the and graph the foci, which is on the transverse axis. Write equations for the asymptotes and graph them. We will be graphing the asymptotes using the reference box. Just writing the equation, we will use the standard form of the equation. So in this case, let's begin. We know x is positive. We know a is 2 because this is a squared. We know b is 5 because this is b squared. Okay. Let's find out c because we will be needing c to find the foci. C squared equals a squared plus b squared. Yes, this is the Pythagoras theorem because it makes 90 degrees angle, right triangle. So c squared equals to 4 plus 25, which gives us 29. And c is approximately equal to 5.4. Now, the first step, write the equation in standard form. This is in the standard form. And graph the center hk. What is the center? 0, 0. Let's write the center, which is 0, 0. Okay, so 0, 0. This is the center. Graph the vertices using the first denominator. First denominator is 4. So we are going to go 2 units up from the center and 2 units down from the center. Okay, now, is this a horizontal or a vertical? It's a horizontal. It's a horizontal hyperbola. So it's going to be like this, that this is the transverse axis, okay, and this will be the conjugate axis. So we know the transverse axis will be, the vertices will be on the horizontal line. So I am going to go 2 units from here, from the center, 2 units from here. Okay, let me use a different color pen. Co-vertices, 5 units up, B. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now I'm going to have the reference box. For the reference box, what we have to go is, from the center we go A units and B units up. B is 5, right? 1, 2, 3, 4, 5 here, to create my reference box. To create my reference box. To create my reference box. Now I'm going to use my dashed line. To create my reference box, please use a ruler. I'm holding my phone in another hand, that's why. Okay. What I just did, this is B on the conjugate axis. I just used, or you can do wherever this X and Y meets, here. This point is AB. One of the other, you could go A, B down, A, B down, A, B up. Okay, once you get this, we will draw the asymptotes. The asymptotes just goes, connects these, the center and the 2 ends of the reference box. So my asymptote will be okay, this is my asymptote. Positive asymptote, another one will be connecting the 2 ends of the reference box and the center. Okay, they help us to draw the hyperbola. Okay, now let's plot the foci. Foci are on the transverse axis. So foci is 5.4, 1, 2, 3, 4, 5.4, somewhere here. 1, 2, 3, 4, 5.4, somewhere here. This is the foci. Foci are always inside the hyperbola. Now this distance will also be 5.4. Because it's a slant distance, we can't go 1, 2, 3, 4, 5.5. That's why we use the distance A and B. Okay, now let's draw our hyperbola. Our hyperbola comes close to the asymptote. Let me use another pen. Let's use it. Come close to the asymptote. Okay. Touches this vertex, which is the edge of the reference box, and exits by getting close to the asymptote. Okay, let's do again. It's gonna come close to the asymptote, touches the vertex, touches the vertex at this point. This is my horizontal hyperbola. Now let's find the coordinates of the vertices. From the center, so this is 2, 0, and the other one is -2, 0. Co-vertices 1, 2, 5. So it is 0 and 5, and the down one, this one is -0 and -5. Foci is 5.4 and 0, and the next one is -5.4 and 0. This point, foci. Asymptotes, the equation. Either you can write your equation by using the linear equation form, starts from 0, and the slope is 1 2 3 4 5 over 2. So you will get the equation will be 5 over 2 x. Nothing is added or subtracted because origin is 0. So one is positive slope, this is the same positive or negative. If you use this formula, plus minus horizontal one, plus minus b over a. B is 5 for that question, a is 2, x minus 0 plus 0, which ends up with the same equation. Okay? So now let's do another one, which is the vertical hyperbola. This is the vertical hyperbola. How do we know that? Because y is positive and x squared is a negative term. So let's find out a. A would be 6, b is 3. How to differentiate between hyperbola and parabola? Hyperbola has a negative sign in between. Hyperbola has a negative, and in ellipse, sorry, not parabola. In ellipse, we have a positive sign in between. Okay. So C would be 36a squared plus b squared, which is 45. So C is equals to approximately 6.7. It's a vertical, so the transverse axis would be the vertical line. Okay, from the center 0 0. Okay, so graph the center 0 0, then graph the vertices. I have to go 6 units up, 1 2 3 4 5 6 units up, 1 2 3 4 5 6 units down. B 3 1 2 3 1 2 3. To get my box, I'm gonna go, they meet here, right? This is gonna be my box here. It tells you how A and B are spread out. Now connect these. Reference box. Okay, let's graph the asymptotes. Connect these. Okay, both go in this end. Okay. Okay. Our asymptotes are here. What else we need is our C. C will be on the transverse axis because it's a vertical one. 6.7, 1, 2, 3, 4, 5, 6.7. Okay, now let's create the branches of hyperbola. It's a vertical one. It comes close to the asymptote, touches the vertex, and exits by getting close to the another asymptote. Okay, the same thing, comes close, touches the vertex, and gets close to the asymptote. And foci is always inside. Okay, center is HK, which is 0 0. The vertices are this one. Okay, so it is 0 and 6, and then the other one would be 0 and negative 6. Co-vertices are 3 and 0, and this one is negative 3 and 0. Foci is on this transverse axis, 0 and 6.7, and the other one is 0 and negative 6.7. The equation for the asymptote you can do, it's a vertical one, so the formula is y equals plus, it's a linear line, so we use y equals plus minus a over b. A over b. So a over b is 6 over 3. 6 divided by 3 is 2, so let me write 2. Center is 0 0, so it's only or you can also go up. 1 2 3 4 5 6 1 2 3. Slope is 6 over 3, which is 2x. That's how you do it. Okay, now let's do the third one, which is in which the center is not 0 0 but other than 0 0. So the center here is 3 and negative 1. Let me write the center 3 and negative 1. A is always on the first one, so A is 4 and B is 1. Okay, fine. C squared equals 16 plus 1. C squared equals 17. C equals 4.1. Okay. Now let's start graphing it. Center 3 and negative 1. So 1, 2, 3 and negative 1. This is my center. Okay, from the center I'm gonna, okay, is the horizontal? Yes, this is the horizontal hyperbola. So my vertices and my foci will be on the horizontal axis. Okay, so from here I have to go 4 units away. So 1 2 3 4 for the vertices, 1 2 3 4 for the vertices. B units up and down, which is 1, so 1 unit up and 1 unit down. Let's have our reference box. Reference box will be here, here, these points. Okay, now my asymptotes will be connecting the two corners of the reference box, passing through the center. So this is my asymptote. The another asymptote will be this one. Okay, now let's plot the point C. 4.1 1 2 3 4. 0.1 close. 1 2 3 4.1 close. So close. So my comes close from the asymptote, touches the vertex, and make sure focus is inside. It's here, touches. Okay, these are my hyperbola. Now vertices, the coordinates of the vertices will be this is the vertices, right? It is 1 2 3 4 5 6 7 and negative 1. So one is 7 and negative 1. The other one is, this one is negative 1 and negative 1. Okay, B, this is B, right? So it is 1 2 3 3 and 0, and the other one is 3 and negative 2. Okay, foci, this is how much? Foci is 4.1, right? So this point will be 1 2 3 4 5 6 7. It is 7.1, and how much down? 1 unit down. 7.1 and 1 unit down, and this one will be 1.1, right? Negative 1.1 and negative 1. Now let's find the equation using the formula. Because it's horizontal, my asymptote, let's do the equations here. Y equals plus, there are two ones, so I'm going to do it separately because the center is not 0 0. If the center is 0 0, it's too easy to identify the asymptotes. Okay, so the equation of the asymptote, first one let's take with positive, and the next one will be with the negative. Positive, so the two ones, let's combine positive, negative. For the horizontal, it is B over A, right? So positive negative b over a b is 1 over 4 x minus 3 plus k, which is negative 1. So let's have our two. The first one will be y equals positive 1/4 and positive 1/4 x, and the positive 1/4 x, and then this multiplies gives me negative 3 over 4 minus 1. Okay, sorry, positive and negative is negative, yeah. So it gives me what? It gives me y equals 1/4 of x. My negative 3 and negative 1 combines gives me negative 7 over 4. Do the math. The other one is y equals negative 1/4 x. Negative 1/4 x and negative 3 combines gives me positive 3 over 4 minus 1. Do the math. It gives me y equals negative 1/4 of x, and it gives me negative 1/4. So my two asymptotes are these: y equals 1/4 of x minus 7 over 4, y equals negative 1/4 of x minus 1 over 4. Okay, I hope you understand the topic.